Section 10.4, add, subtract, and multiply radical expressions. So when you're adding and subtracting these radical expressions, just like with variables, the radicals must be the same in order to add and subtract them. So we must have like radicals to add or subtract. So let me show you what I mean. Here we've got 7 times the square root of 5 plus 2 times the square root of 5. So what this is we've got 7 of these plus 2 more of these, so we can do the whole backwards distribution thing and say this is 7 plus 2 times the square root of 5, because both of these are square root of 5. So 7 and 2 are 9, so 9 square root of 5, and you're done. All right, so if these are both the same, which in this case they are, what you're going to do is look at your coefficients. You've got a 6, and if there's nothing in front, remember that's a 1. So you've got 6 plus 1 times the third root of 4, and that's going to equal 6 plus 1 is 7, third root of 4. Same thing here. We've got the radicals are alike already, and your variables are alike. So now you just have the 6x minus 2x. So 6x minus 2x is just 4x. 4x times the fourth root of 3x, because your root is exactly the same. All right, if the root is the same, this is easy. It's just like adding like term, combining like terms. Just pretend like if it's the same, just pretend like it's x, and move on, and then tag it on to the end. Now, if you've got ones that are different, you can't add them. Remember, they have to be alike. But in this case, we've got some that are alike, and so what we can do is use that commutative property and move these around. So 8 square root of 3. Now be careful when you're moving it to keep the sign with it. This negative sign has to go with this, the 5 square root of 3. Plus 6 square root of 2 plus 3 square root of 2. So all I've done is I've moved them around so that the square roots that are the same are together. So now I can simply add them. 8 minus 5 is 3. Square roots of 3, and 6 plus 3 is 9. Square roots of 2, and then you're done. Because at this point you cannot combine these any further because the radicals are different. And in order to combine them, remember, the radicals must be the same. All right? So what happens if the radicals aren't the same? Oh, never mind, we just don't do it, we walk away. No, we simplify it. All right, so we look at the square root of 12, and we say, well, I happen to know that 12 is 3 times 4, and 4 is 2 times 2. So you're going to simplify this first and say, well, this is the square root of 3 times 2 times 2, and 2 is my go fish number, and so there's 2 2's. So I've got 7 square root of 3 plus 2 square root of 3. And now 7 plus 2 is 9. And where's my eraser? Oh, down here by me, that's handy. So 7, 8, 9, we have 9 square roots of 3. Easy. Okay, well, what if we have numbers and letters and, oh my word, what are we going to do? Well, they're different, so simplify them. Okay, we want to add them together. They have to have like radicals. Let's simplify them as far as they will go and see if just maybe they're going to be the same when we get finished. So 48 is 6 times 8 is 48. 2 times 3, 2 times 4, 2 times 2. So 48 is 2 times 3 times 2 times 2 times 2. And then times x times x times x, because there's 3 of those. And so, let's see, let's finish simplifying this. We've got 2 2's here, and ooh, check this out. We've got 2 2's here, and we've got 2 x's here. So this all simplifies down. I should have given myself more space. We've got one set of 2's and another set of 2's. So 2 times 2 is 4. And one set of x's comes out. And what's in between here now is 3 and an x. Has to stay under. All right. So now let's simplify our 12x. I'll tell you what, I'm having a hard time. Here we go. The 12 we actually just learned was 3 times 2 times 2. Remember that? So 3 times 2 times 2 times 1, 2, 3 x's Coefficient number is 2, so we've got one set of 2's, one set of x's, so we have 2x, and then the square, what's left under is a 3 and an x. So now we're adding 4x times the square root of 3x and 2x times the square root of 3x. So now we've got the same radicals, which is what we needed. And these both have, ooh, bonus, these both have an x. So we've just got 4 plus 2. 4 plus 2 is 6x, 6x's times the square root of 3x. All right, so treat it just like a variable. All right, as long as it's the same, you can combine it. If it's not the same, you got to just leave it. All right, so what happens now if we want to multiply? So that was all adding and subtracting. The bottom line is you got to get like radicals, and then you just combine the coefficients in front of them. You don't do anything with what's inside. That stays the same because we're undoing the whole distribution thing. Now, if you're multiplying, you're going the opposite of the distribution. You're actually going forward with distribution. So you've got to take the square root of 3 times the square root of 3 and the square root of 3 times the square root of 15. So the square root of 3, so you're going to take the square root of 3 times the square root of 3, and then you're going to add that to the square root of 3 times the square root of 15. And the square root of 15 is 3 times 5. Do you see where I get those parts? Square root of 3 times the square root of 3, square root of 3 times 15. So this is the square root of 3 times the square root of 3. They're both under the box. And this is the square root of 3 times 15. 3 times 5 is the 15. So this can come out and be just 3. And this can come out, oop, don't lose your plus sign, and be 3, but there's a square root of 5 left. So now, because this one is a whole number and this one has a radical, you can't combine them because they don't have like radicals. So you're done. And that's it. All right. Same thing happens if you have numbers that are and aren't under. You just have to multiply what can. The parts that you multiply the parts together that are alike. So let me show you what I mean. So 2 square root of 6 times 3. So you're going to have, oh, that was lovely. Where's that eraser again? 2 square root of 6 times 3 is going to be 2 times 3 times the square root of 6. Okay, I'm putting my whole numbers together now because this 3 isn't under the square root, so I'm not going to put it under my square root. Now you're going to take the 2 times the square root of 6 times the 5 times the square root of 5. And when we do that, remember, we multiply the whole numbers, so 2 times 5. And then you keep under the box what's already under the box, so 6 times 5. And this 6 is 2 times 3, but 2 and 3 and 5, there's nothing, there are no pairs in that, so I just left it with the 6. So now we simplify what we have. 2 times 3 is 6, square root of 6, plus 2 times 5 is 10, square root of 6 times 5 is 30. And you're finished because square root of 6 and square root of 30 are not the same thing. All right, I have a couple more things for you. If you're multiplying binomials, don't forget that you have to use FOIL. All right, so remember when we multiplied a monomial times a binomial, we distributed that through. Remember when you're multiplying by binomials, you've got to use FOIL. You've got to multiply every part by every part. So don't forget, first terms is 2 times the square root of 5, and that you just have to kind of leave 2 times the square root of 5. That doesn't simplify any further. And then the outside terms, so 2 times negative 6, so minus 2 square root of 6. Then the inside terms, plus the square root of 3 times the square root of 5, so 3 times 5 is 15. Because they're both under the box, I can multiply them together. And then square root of 3 times the square root of 6, minus the square root of 3 times the square root of 6. And now this, I'm going to split up into 2 times 3. Do you know why? Can you see it? Can you see it? Because there's a pair. 3 times 3 can come out. And that becomes 3 square root of 2. So now the whole thing is going to be 2 square root of 5, oops, minus 2 square root of 6 plus square root of 15 minus 3 square root of 2. And that is very small. Can you see that even? Oh my word. Okay, and because you've got a square root of 5, square root of 6, square root of 15, and square root of 2, they are all different. So you have to just leave it all strung out all over the place. All right, you can't combine anything because nothing is alike. All right, in this one, however, there's going to be something alike. So I'll show you what you do then. 3 times the square root of x times 2 times the square root of x is 3 times 2 times the square root of x times x. And then we're going to, well, you're going to add, but this is a negative, so it's going to be minus 3 times 5 times the square root of x times y. And then the inside terms are going to be plus 2 times the square root of x times y, x and a y, minus 5 times the square root of y times y. Did you see where I got all those pieces? First terms go here. Outside goes here, inside here, and last terms here. So now we just simplify and combine anything that will. 3 times 2 is 6, and the x's are going to come out because you've got a pair of them. So 6x minus 3 times 5 is 15, and the square root of xy will not simplify any further because there's no pairs, plus 2 times xy minus 5, and then the y's are a pair, so they come out. Now if you'll look, the x and the y are different, but this square root of xy in the middle is the same. So you can put those together. So your final answer then is going to be the 6x, and then you're going to combine a negative 15 and a 2. So because you're going to add them, but because it's a positive and a negative, you subtract and use the sign of the bigger. So 15 minus 2 is negative 13 square root of xy minus 5y. Whew! All right, so far so good. Now, when we do this, I said that, okay, sometimes nothing can combine. In this case, if you've got the same types of variables, then your middle term can combine. There is one special case where our middle terms totally drop out, and this is so handy in lots of different ways. It's when we use conjugates. You want this in your notes. Hint, hint, hint. You want to know what a conjugate is. A conjugate is a binomial with the same terms, but one is plus and one is minus. So here's a set of conjugates. 2 plus square root of 3 and 2 minus the square root of 3. The terms are exactly the same. The 2 and the square root of 3 are exactly the same, but one is positive and one is negative in between. One is plus and one is minus. Let me show you why that's handy. All right, when you multiply your outside terms, you get 2 times 2 is 4. Multiply your, I'm sorry, that was the first. Now multiply your outside terms, and you get 2 times the negative square root of 3, so minus 2 square root of 3. Now your inside terms, square root of 3 times 2, so plus 2 square root of 3. And your last terms are square root of 3 times a negative square root of 3. So square root of 3 times square root of 3 is going to be just 3. Now check this out. This is so cool. Okay, so a negative 2 square root of 3 plus 2 square root of 3 are exact opposites. So if you take 2 square root of 3 minus 2 square root of 3, they totally drop out and go away. So now all you have is 4 minus 3, which is just 1, and you're done. Ha ha! Check that out. Okay, same thing one more time. What is a conjugate? A conjugate are the same terms, 5, 3 square root of 3, 1 minus and 1 plus. It doesn't matter which is first or second. If the terms are the same, 1 minus and 1 plus, then it is a conjugate. So if I ask you give a conjugate for this number, you need to be able to do it. That is another huge hint. All right. First terms, 5 times 5 is 25. Outside terms, 5 times 3 square root of 3 is 15 square root of 3. Inside terms, and in all honesty, if you know they're conjugates, you don't even have to multiply these outsides and insides, all right, because you know they're going to drop out. I'm showing you that one more time that they will, but as long as you recognize them as conjugates, you don't even have to multiply the outsides and insides. So the inside is going to be negative 15 square root of 3, and then the last terms are going to be 3 times 3, and check this out, we're going to do it over here. So 3 3 times 3 on the outside, and then square root of 3 times 3, which is another 3. So 3 times 3 times 3. See where I got that? So this 3 times 3, and this square root of 3 times square root of 3 is just 3. All right, so 3 times 3 is 9, 9 times 3 is 27, and it is negative, so minus 27. These two drop out. 25 minus 27, there's a positive and a negative sign, so you subtract and get 2. The 27 is bigger, so negative 2 is your final answer. Ta-da! All right, there we go, adding and subtracting and multiplying. I think you can do it.